How's it going, guys? John with Freedom Machine Works, and today we're going to talk about Wiselite Sterlings. Wiselite Sterling bolts in particular. Now, if you're watching this video, you've probably heard that Wiselites are notorious for breaking off the firing pin tips. So today we're going to talk a little bit about what you can do to reduce that risk and what you can do if that happens to you. So the first thing you want to do is disassemble your bolt and get everything cleaned up. So there really isn't much disassembly involved other than the extractor. And to do that, I just use the striker itself. Push this pin through. The extractor will fall out. And this spring plunger can be a little difficult to get to. You got to have a pair of needle nose pliers with the right geometry, or at least a pair that you don't care about. You can grind the sides down on. Grab a hold of that plunger and just pull it out. So from that point, you can get everything cleaned up and we'll move on from there. So the next thing is all of these sharp edges. So all of the sharp edges around the denial bar cut out, the sharp edges around the striker channel, even these corners down through here. Remove all of these sharp burrs, just roll the edge so they're no longer sharp. From there, I would get this track in the bottom. You can see that it has a rough surface finish. It's just a rough drilled hole that they put down through there. So in order to clean that up, what I use is a piece of steel with a slot cut in the end of it. You can use a bandsaw, a Dremel tool, or whatever. You can see it doesn't even matter really. And a piece of emery cloth. Somewhere around 220 grit or finer. I find that 220 works pretty well. And wrap it up around there and stick it inside the channel. And if you leave this spring in, so the Wiselite springs are quite difficult to get back in. To be honest, I haven't even gotten one back in, but that's because we have our own springs. Usually I just pull them out and put one of our springs in them. So with that being the case, if you do leave your spring in there, if you're not replacing the original Wiselite spring, I would recommend just leaving it alone. Whenever you put this in there to clean up that channel, you want to spin this sandpaper in the opposite direction that your spring is wound so that you don't end up catching the end of the spring and opening it up and destroying the spring. So basically slip this down through the end. You can use some WD-40 or other light oil, and it'll keep your paper cleaned out. And just run it back and forth. Now I've done this one already and it looks worse than it is, but the whole idea here is you want to smooth out the highs just to get an average sort of pattern here. You don't need it to look like a beautiful honed surface. By the time you got that far, this track would be it would be wallowed out into a larger shape that would cause more problems down the road. So essentially just make it nice and smooth. Smooth out everything as much as you can until you see that it's not really making too much difference, and stop at that point. Now the reason that matters, whenever the striker rides in that track, the sear catches on the end of it right here. So when the bolt comes back forward, it's dragging the back side of the striker here or the back side of the firing pin through that rough channel, and it can get caught and cause binding issues, especially here in the beginning when this firing pin tip is still stuck through the bolt face. So we want that to be a nice smooth transition so it can grab it and just pull it right out without any issue as far as that channel is concerned. So the next part, where this angle is just clearance for this section of the striker. That's really all that's there for. However, whenever they mill this slot and they mill this slot, they use, it's done with two different tools or two different operations, and it ends up leaving material here and right here on this side. So you can see I've already filed this one. So you want to file this until it blends this section here. That way when the striker is installed, it doesn't get tight right in this section as it's pushed down, or as it comes in contact with the the primer. So we want that to be a nice smooth transition through there. And finally, what you can do is the hole that goes through the end, that comes into the bolt face, they're basically just two drilled holes, so there's not a great transition there as far as an edge break. So what I did is I made this tool here, and it's just a piece of round stock, and I drilled a hole through the end of it, heated this with a torch, and inserted this carbide burr into it. So essentially when it cooled down, it made a shrink fit on that burr, and it's nice and tight. You can slip that burr down through the end and spin that by hand in order to create a chamfer or a smoother transition when that striker comes through at Mach 2 or whatever, hits that primer. It won't have to smack into the bottom of the bolt before it finds the hole and comes through. All of those things cause fatigue whenever if the striker tang gets caught, if this section rubs through that rough channel, or if this is smacking into the end of the bolt before it finds that hole. They cause fatigue in this pin, and they cause them to break almost exclusively right back here. Basically right where you can see that's inscribed circle all the way around there. That is where they break. So you want to smooth out anything that might cause a problem there. And that's really all there is to that. There's only so much that can be done in order to smooth that out, but it's a simple design, so it's not too bad. Now, if you do break firing pin tip, you're not completely out of luck, because we actually manufacture brand new striker assemblies for these, and they're based directly off of the original Sterling striker. So this one was manufactured by Sterling in England, and these are our new striker assemblies here. And they are essentially identical to the originals, down to the heat treat hardness. I mean, they are, you can see we checked this in multiple places to check with a Rockwell hardness tester on the pin and on the tang itself in order to get repeatable results as far as that goes before we committed to heat treat numbers. So they are as close as you can get to the original. Now the difference here comes in with the overall length. So if you were to use these pins as they ship in an original Sterling bolt, they would run fine because the length is the same overall. They hold that tolerance a lot tighter on an original Sterling bolt than they would on Wiselite bolts, or one that was converted roughly based on Wiselite numbers in someone's shop. Now that doesn't mean that they won't run in a bolt, at the original length without any issue in a Wiselite bolt. It's just we're going for optimal numbers here. We want to get things right. Now, in order to do that, we need to measure the firing pin protrusion. And what that is, so we stick the striker down through, stick it up. We want to know how far that tip protrudes through the backside of that cartridge pocket. Now, the ideal number for a Sterling bolt is between 30 and 45 thousandths. It doesn't mean that it won't run if it sticks out 60 thousandths, but you've got to think the farther that sticks out, the more it has to drag back through that hole whenever the striker goes to reset. Not only that, but if you have a failure to fire because the striker doesn't catch the sear doesn't catch the striker tang, if it is able to stick out too far, it has a potential for slam fires and other things like that. Now, saying that, or having said that, the original Wiselite firing pins are also not held to a very consistent length standard. So I've checked some of these original ones, and I've seen them with 60 thousandths of firing pin protrusion, or 40 thousandths, or whatever. And a lot of that has to do with the distance between this surface here, this surface right here, where the striker stops against the inside of the bolt, So wherever they machine that to the inside of that cartridge pocket, that overall dimension right there is not reliably the same across every bolt. So what I suggest doing is removing that extractor, sticking the holding that firing pin through like this. And what you want to do, well, before doing that, what you want to do is measure from this bolt face to the bottom of that cartridge pocket. And it's almost always 78 to 81 thousandths of an inch deep. Then from there, bring that firing pin tip up through, and then you're going to measure from, again, this bolt face to the top of the firing pin. And, you know, subtract that number from the overall depth. That gives you your protrusion. So at that point, you can take a file or whatever you prefer, and file down the the end of the tip, put it back in, check it. You want to get that down to about 30 to 45 thousandths of an inch, and then just kind of put a nice radius on it. It doesn't have to be perfect. I mean, the original bolt here, or firing pin here, doesn't have a perfect radius on it either. And that will give you reliable operation, and it will reduce the chance of slam fires significantly, especially if the spring is still in place. Now, like I said, or I'm not sure if I mentioned it, but the original springs, Century springs, don't like to come out of there, or go back in rather. Our springs are not too bad as far as that goes. How you remove one is you want to take a pick and get down into the bottom of the spring, pull it out from the bottom like that. If you try to grab it from the top and pull it this way, same thing with the Century springs, you'll end up stretching that spring, and it'll lose its form and it won't go back in properly. And in order to replace one of these springs, I actually use a T25 Torx screwdriver, and just stick it in the end of the screw, and you want to turn it so that it puts a tension on the spring and makes it a smaller diameter essentially. So we'll go in, put some light pressure into the bottom, twist that screwdriver, and it'll go right down in. It'll sit straight in the hole, and it won't give you any problems as far as that goes. So that's how you want to install them. And if you need springs, we sell spring kits that you'll get a new striker spring, striker return spring, and the short recoil spring to basically freshen up. I mean, between those and the striker, you've essentially freshened up the entire bolt side of the operating system. In a later video, we'll discuss what we can do with the fire control group in order to improve reliability there, and essentially eliminate the risk of like double fires from the striker not being caught by the sear and things like that. But yeah, this is the first time something like this has been available, as far as I know. This is basically everything you need to keep your Sterling going indefinitely. Well, thank you for your time. See you on the next one.